All right, so let's do number 5 here. So if we start by dividing by 240 on both sides, we wind up having 1.004 to the 12n equals 2. By doing that, we've essentially solved for the exponential piece. So now we can take the ln of both sides, and we can then take that 12n and put it in the front. So now we have 12n times the ln of 1.004 equals the ln of 2. Now I see how we have both a 12 and an ln that have to be divided to the other side. We can do that all in one step, and that's what I'll do here. We just have to remember, when you plug this in the calculator, you have to be very careful. So if you have the newer calculator, here's really where you want to use your fraction button. If you have the older calculator, you want to put this all in a parenthesis here. Now if you type that all into your calculator, so the ln of 2 and then all that in one big denominator, you wind up getting an answer of 14.469 ... and it says round to nearest integer, which means whole number, so n equals 14. For number 7, first thing we have to do is divide both sides by 100. So I get 0.3. I'm going to use the decimal there because that's a nice decimal. Same thing with the 1/2. I'm going to change that to 0.5 just to make it easier to type in the calculator. So decimals that terminate or nice decimals, I would use them. Then we could ln both sides. And then we want to multiply 63 by both sides and divide the ln of 0.5. If we do that, we get a t-value of 109, and it says nearest tenth, so 0.4. So those are the 2 questions from the notes that I asked you to try for homework. Let's take a look at the actual homework questions. So for this first one, we'd start by taking the ln of both sides, so the ln of 10 to the x equals the ln of 30. So we get x ln of 10 equals the ln of 30, or x equals the ln of 30 divided by the ln of 10. So that's going to give me an x value of 1.5. It doesn't say what to round to, so we'll just go nearest tenth is fine. For the next one, if we add 4 to both sides, we have 2 to the 3x equals 12. ln both sides, so we'd have 3x ln of 2 equals the ln of 12. Again, just like that problem from the notes we just talked about, when you divide this, those of you with the older calculator that don't have the fraction button, you want to put a parenthesis here. If not, it will not work. So then if we go and solve for x, type that in our calculator, we get 1.2. For the last one, if we take the ln of both sides, I know 1/16 is a decimal, so see if it's a nice decimal. It's okay. So it's 0.0625. Only because it's easier to type the decimal in, but you could do the fraction too, it's up to you. So ln both sides. Whenever you ln both sides, remember the exponent comes down, so like we said in class, you could kind of do that all in one step. So I would divide by the ln of 2. Then the rest of this is going to be us adding 1 and dividing by 3. So that's going to change my logarithm to become the ln of 0.0625 divided by 3 ln of 2 plus 1. Again, just like the last example, we want to put a parenthesis here with the old calculator. And if you put that in your calculator correctly, you should get negative 0.3 repeating, or negative 1/3. All right, so let's take a look at the last 4 here. These are a little bit more difficult than the ones above, just because there's more steps, not that they're a higher difficulty level. So for this first one, we'd start by dividing by 300. So I'd have 2 to the t over 5 equals 2. If I ln both sides, I'm going to get t over 5 ln of 2 equals the ln of 2. We would divide by the ln of 2 on both sides. So I'd have t over 5 equals 1, because that is 1. Multiply both sides by 5, and I get t equals 5.000. Remember, it does say round to the nearest thousandth, so even if it doesn't have decimal places, you got to put them in there. For the next one, if I start by dividing by 40, I get e to 0.027t equals 5/4, which you can make a decimal if you want. I'll leave as a fraction, totally up to you. This is a good example of why we want to use natural logs, because when I take the natural log of both sides here, we get an ln of e. ln of e, remember, is just 1, so it doesn't matter. I can then go through and divide by the 0.027, and I get t is equal to 8.265 if I type that in our calculator. For the next one, we'd start by dividing by 800. If I do that division, I'm going to get a decimal. So I'll just change the half to 0.5. It's easier to type in the calculator. Equals 0.15. ln both sides. So I'd have 0.347t ln of 0.5 equals the ln of 0.15. Divide both the 0.347 and the ln of 0.5 to the other side, giving us t. But remember, if you have the old calculator, you need this parenthesis. If you type that in the calculator correctly, you should get 7.888. And for the last one, there's 2 steps before we can take the ln of both sides. We have to first subtract the 68. So that gives us 102 equals 136 e to the 6k. Divide the 136. If you do that, you get 0.75, so that's a nice decimal, we'll use it. E to the 6k. If you ln both sides, ln 0.75 equals 6k ln of e. Remember, the ln of e is just 1, so I can just cross it off. Divide both sides by 6, and I get a k value of negative 0.048. Negative values can come up here as the exponents, so don't freak out if you get them. Hopefully this helps. I'll see you tomorrow.